Welcome back. This outcome shifts from choosing software to actually using it well, entering data accurately, and then putting the built-in features and functions to work to shape that data. There are two threads to this outcome. First, entering and editing written, numerical, and pictorial data accurately, and second, justifying the functions or formulas you use to format and manipulate that data. The order matters because accuracy comes first. A formula is only ever as good as the data you feed it. Get the data wrong, and every clever calculation on top of it is wrong too. Let's name the three kinds of data we'll be handling. Written data is words and characters, names, sentences, labels, and headings. Numerical data is numbers used in calculations, prices, marks, quantities, dates, and pictorial data is images, photos, logos, charts, and diagrams dropped into a document. Underpinning all three is accuracy, getting the data in correctly, completely, and free of typing slips. Entering data carefully is a discipline worth building. Check as you go, because a single wrong digit can throw out a total or a decision. And in a spreadsheet, make sure numbers are entered as numbers, not text, or the calculations simply won't fire. Keep your formats consistent for dates, currency, and units right across the file. And a real-time saver, use data validation and drop-down lists to limit entries to sensible values, catching mistakes before they happen. It really is a case of rubbish in, rubbish out. Editing is what you do once the data's in, correcting it, updating it, reshaping it. The core tools are the ones you use every day: cut, copy, paste, and the ever-forgiving undo and redo. Find and replace is the power move, changing every occurrence of a word or value in one sweep. And spell check, grammar check, and autocorrect quietly mop up written errors as you go. Checking your work deserves its own moment. Proofread written data on screen, and where it really matters, on paper too, because errors hide differently in print. Verify numbers against the original source, a receipt or a register, and cross-check totals against a rough mental estimate. Does the spreadsheet's answer even look right? For anything important, ask someone else to cast an eye over it. A fresh pair of eyes catches what yours have started skipping past. Here's a familiar scene. A tutor typing 30 learners' test marks into a spreadsheet to work out averages. The marks go in as numbers so that average and sum will actually work, and a validation rule rejects anything above 100 or below 0, catching a slip of the finger. The tutor then spot-checks a sample against the paper mark sheet, because a mark keyed as 87 instead of 78 would quietly distort the whole class average. Only once the data's verified do you trust the formulas sitting on top of it. Pictorial data has its own handling. You insert an image with insert, then picture, and resize it by dragging a corner handle so the proportions stay true rather than stretching it out of shape. Crop away any unwanted edges. Use text wrapping to sit it neatly alongside your words, and compress large images so the document doesn't balloon in size. And do add alternative text. It makes the image accessible to screen readers and records what it's actually there to show. To pull those together, each data type has its own way in and its own way of editing. Written data is typed and then tidied with spell check, find and replace, and styles. Numerical data is typed as numbers and shaped with number formats, formulas, and validation. And pictorial data comes in through insert, picture, then gets cropped, resized, compressed, and given alt text. Different data, different toolkit. Now to the engine room formulas, and functions. A formula is an instruction that calculates a result, and it always starts with an equals sign, something like equals B2 plus C2. A function is a ready-made formula the software gives you, such as sum, average, or if. The pieces they work on are cell references. The address of a cell like B2, so the formula uses live data, and operators, the plus, minus, times, and divide symbols that do the actual arithmetic. Let's meet three of the most useful functions. Equals sum of B2 to B4 adds up a range of cells in one go. Equals average of B2 to C2 works out the mean of those marks, and equals if D2 is greater than or equal to 50, pass, otherwise fail, makes a decision straight from the data. Because they all lean on cell references, the results update the very moment a number changes underneath them. It's worth knowing a handful more that come up constantly. Sum adds a range, average finds the mean, and max and min pick out the highest and lowest values, brilliant for spotting the top mark or the cheapest price. Count tells you how many cells actually contain numbers, and IF, as we saw, returns one answer if a test is true and a different one if it's false. Together, these cover a huge share of everyday spreadsheet work. Here's a subtlety that trips people up: relative versus absolute references. A relative reference like B2 shifts as you copy a formula down a column, which is usually exactly what you want. An absolute reference written with dollar signs as $C $1 is locked and never moves, perfect for a fixed value like a tax rate that every row must point back to. Get this right, and you can write one formula and fill it down the whole column with confidence. Let's build something with those pieces. A sheet that averages each pupil's 2 tests and flags a pass or a fail. Equals average of B2 to C2 gives each pupil's average filled down the column, and equals if D2 greater than or equal to 50, pass, otherwise fail, labels every result automatically. A sum and a max then summarize the class total and the top mark. The justification writes itself. The functions strip out manual arithmetic, cut errors, and update the instant a mark is corrected. Doing that by hand for 30 pupils would be slow and painful. Once the numbers are right, formatting helps them speak. Number formats show data as it should read, currency with a pound sign, proportions as a percent, or measurements to 2 decimal places. Conditional formatting colors cells automatically, say red for a fail and green for a pass, so patterns jump out. And simple touches, column width, alignment, bold headings, turn a wall of figures into a table someone can actually read at a glance. It's easy to forget that word processors have functions too, not just spreadsheets. Styles apply consistent heading formats and drive an automatic table of contents that renumbers itself as you write. You can insert page numbers, headers, and footers that update across the whole document. And tables can even do simple sums. Mail merge is the standout, slotting data in automatically to produce personalized documents at scale. This outcome asks you not just to use a function, but to justify it, to explain why it's the right one. Start from what the task actually needs. A total points to sum, a mean to average, a decision to if. A strong justification ties the function to the outcome. Something like if is used, so each result is labeled pass or fail automatically, without checking every cell by hand. Naming the function is half the answer. Giving the reason it's the best fit is the other half. Take a shop that needs to flag any product where stock has dropped below 10 units. Equals if, B2 less than 10, reorder, otherwise okay, checks every product automatically, where the alternative, reading 400 rows by eye, is slow and unreliable. As stock levels change, the flags update the instant new data lands. The justification is clear. IF is chosen because it applies one rule consistently across all the data, faster, more accurate, and repeatable than any manual check. A few error messages are worth recognizing because they're clues, not disasters. Hash div/0 means a formula is dividing by 0 or an empty cell, so check the divisor. Hash ref means a cell the formula relied on has been deleted, so fix the reference. If a formula shows up as plain text, you've usually missed the equals sign at the start, and a total that looks wrong often traces back to a range that's quietly missed a row. Let's gather it all up. Data comes in three kinds: written, numerical, and pictorial, and it must be entered accurately because errors ruin everything built on top. Editing tools and validation help keep it correct. Formulas start with an equals sign, and functions like sum, average, and if are ready-made calculations that update themselves. Relative and absolute references, number formats, and conditional formatting control how data is worked out and displayed. And justifying a function means naming it and explaining why it's the best fit for speed, accuracy, and consistency. So we've gone from getting data in cleanly to making functions and formulas do the heavy lifting, and crucially, to justifying the choices we make. To build real fluency, the Microsoft Excel step-by-step book is a superb hands-on companion for functions like IF and the reference tricks we covered, and the free GCF global tutorials let you practice them live. The Microsoft Learn worked examples are ideal for seeing formulas and mail merge in action, and the ICDL materials round out the spreadsheet skills nicely. Have a look through the ebooks and journals on the Moodle for this unit before you sit down to the assignment.